Okay, Algebra 1, Lesson 40, Simplifying and Evaluating Expressions Using the Power Rule of Exponents. The power rule of exponents was whenever I take an exponent to an exponent, okay? And what we've seen so far is where if I have, and what you were working with just a little bit ago with some of the practice or some of the questions from our homework lesson, where if I'm distributing or multiplying a term by a like term, and they both have exponents, we add their exponents, right? But whenever we take an exponent yet to another exponent, I'm actually multiplying those exponents, okay? Does that make sense? Okay, and that's basically what's going to get described here. So in previous lessons, we've explored expressions involving exponents. Several rules and definitions have already been developed. We already know that anything to the 0 power is 1, correct? Okay. Anything to the first is itself. If I have, and this is, it's not typically how we see them written out, but if I had something like b to the m divided by b to the n, that's going to be b to the m minus n. I actually subtract those exponents, right? I subtract the numerator exponent by the denominator exponent, correct? All right, we're kind of familiar with that. If I multiply terms, so if I have, changed gears, this is what we were working with from our last lesson, is b to the m times b to the n. That's going to be b to the m times n. And we're just using m and n as placeholders for numbers. If m was 1 and n was 2, right, I'd get b to the 1 times 2 or b to the second. Okay, where we're just, or I'm sorry, adding, not multiplying. That's the very thing I didn't want you to get out of that. Okay, where we're taking 1 plus 2 and we're getting b to the third, right? Yes? Okay, when we're working out questions tomorrow from our homework, I want to know that more than 2 people heard what I was saying today. Okay? All right, so we see some of this stuff worked out. If I have, and this is the big part of yesterday's lesson, if I have b to the negative n and I want to get a positive exponent, I actually drop b below the division bar, negative n becomes positive n, correct? Just give me like the bobblehead thing, all right? Just give me something that says, yeah, got it. Okay, move on. If we don't have it, let me know that too. That way I can stay put and get this nailed down so that I'm not moving past something that you don't understand. But there's another property of exponent that involves raising a power to a power. Okay, and that's called the power of power property. The pattern developed in the exploration leads to the power of a property, and that's where we get this rule. If m and n are real numbers and x doesn't equal 0, then if I have x to the m to the n power, that's going to be x to the m, fix this, x to the m times n. People, once you learn this, the big problem that you're going to have is knowing the difference between this and okay, kind of fell off there. Those two things people flip-flop all the time. Okay? When I have a power to a power, I multiply exponents. When I have a base times a base, I add exponents. Okay? But the mistake is thinking that because I see multiplication here, that it's going to be multiplication there. It's not. Okay? Can we remember the difference? I hope so. Okay? The power of a power property and a product property of exponents can be used together to formulate a rule for the power of a product. If we look at the expression, and I'll write it so it looks a little bit more like we're used to. Right? If I have 5x squared cubed, okay, the outer exponent of 3 means to use everything inside the parentheses as a factor 3 times, or to multiply 5x squared 3 times. And we see it expanded down here. Okay, 5x squared to the third is 5x squared times 5x squared times 5x squared, or okay, well, we can find 5 times 5 times 5, right? Okay, that's 125. And because these are the same basis, I can add those three exponents. 2 plus 2 plus 2, right? What is 2 plus 2 plus 2? X to the 6th. Now I can understand as I look up here that I'm taking 5 and cubing it. Okay, 5 times 5 times 5 is 125. And 2 to the, or x squared to the third is the same as 2 times 3, right? I'm getting the same 125x to the 6th, but you're seeing it expanded here. Okay, if I understand the expansion and what's actually happening whenever I take something to an exponent, then I'll understand why I multiply instead of add. Okay? I need like a cricket sound maker. I can like whenever I'm not sure if we get it or not. Okay? Do you feel like you get it? Okay. So you see, it's 5 times 5 times 5 times x squared times x squared times x squared. 5 to the third times x to the 6th, 125 x to the 6th. And this pattern summarizes that power. All right. So if m is a real number with x not equaling 0 and y not equaling 0, then x y to the m equals x to the m times y to the m. So that's another thing to realize. X, y to the m. That m is being applied to the 1 here and the 1 here. So I'm getting, it actually splits x to the m, y to the m. Okay? I'm applying it to their individual exponents. So if I saw something like, let's try a to the third b to the n. That's going to be a to the 3n, b to the n. Okay? Probably the harder one to see, though, and just it's for whatever reason how our brains work, but let's try h k squared cubed. Okay, what's that going to be? K to the 6th. Okay? Okay, because 1 times 3 is 3 and 2 times 3 is 6. Okay, it's h times itself 3 times and k squared times itself 3 times, so 2 times 2 times 2. Or sorry, 2 plus 2 plus 2. Okay, for the rules of exponents we apply to many expressions with powers. When simplifying expressions, we want to be sure that we're continuing to follow the order of operations. All right, so we'll come back to that little blank page there. We want to look at this. All right, hopefully these should be fairly simple for us. Okay, we can see this. So the first thing I do, I've got 3x to the 6th, y to the 4th squared. So what happens to the 3? What does it become? Okay, what's 3 squared? 9. Okay, Abby, I just want to make sure that you're with me. What's going to happen to the x? Is that going to be to the 8th or to the 12th? Yeah, the x. Okay, so that's running into the very problem that we're concerned with. Okay, so let's look at it like this. We'll go ahead and show it expanded. This is 3x to the 6th, y to the 4th, times 3x to the 6th, y to the 4th, right? In this case, what do I do with the exponents here? Add them. So what's 3 times 3? 9. All right, so I have x to the 6th times x to the 6th. So you said add the exponent, so I'm going to get x to the what? 12th, right? Because 6 plus 6 isn't 8. So I'm not adding that 6 and 2. I am multiplying. So what should I get for the y? It's y to the 4th squared. So even without looking down here, I should get y to the look at the numbers. What's the number over y here? What's the exponent for y? 4. And I'm taking it to the power of 2. So just how you multiplied 6 times 2, you're going to do what with the 4? Okay, and what's 4 times 2? 8. Okay, so I should get 9x to the 12th, y to the 8th. Okay? All right, let's see. Blatant, we have negative 3, ab to the 5th. I think that's to the 5th. I'm going to say it's to the 5th. To the 3rd. Okay? So what number do we start with, or where do we begin? Well, negative 3, right? Think of it as distributing the negative. So negative 3 to the 3rd. So that's negative 3 times negative 3 times negative 3, correct? All right, well, what's negative 3 times negative 3? Negative 3 times negative 3? Are you sure? You're sure it's 9? Okay, 9. So now we need 9 times negative 3. What's that? Negative 27. That's important, okay, because we see some positive 27s up here. Okay, so we need negative 27. All right, this next part is a times a times a. They're all a to the 1st, right? So what is my a value? A to the 3rd. Okay, and now I have b to the 5th to the 3rd. All right, do you know what that's going to be? You're cubing that 5. That's not what we do. I feel like we're not catching on here. All right, when I take an exponent, x squared to the 10th, is that x to the 12th, x to the 20th, x to the whatever 2 to the 10th is? What is it? X to the 20th. So if you knew we're going to multiply 2 times 10 there, why did we take 5 to the 3rd and get 125 there? It's the same thing. We're doing the exact same thing. Okay, what should it be? B to the 15th. Okay, so I should get 27a cubed b to the 15th. Let's see, I think that's right here. How many of us feel like we're getting it better? We're still not all the way there yet. Okay. All right. Let's do at least one more here, and then let's see, what time are you guys out of here? 48. Actually, let's skip to some homework problems. Okay. All right. 40. This is... All right. Once you look through there, pick out one. Page 251. Pick out a homework question from the letters. From the letters. It goes A through G. You could pick one at random at this point. What? Okay, I heard F from multiple people. F. Okay, we've got 9, A, B, negative 2, B to the negative 2, squared times 2A squared, B to the 4th. All right, this has order of operations in it, okay? Order of operations tells me grouping symbols, then exponents. All right. Can I simplify anything inside either of these grouping symbols? Yes or no? Can I simplify anything inside the parentheses on the left-hand side? Can I simplify anything in the parentheses on the right-hand side? No. Okay, that brings me to exponents then. Which exponent do I want to apply? -2? This 2. All right, and I'm going to distribute it to each of these things. Okay? Christian, what is 9 squared? 81. Okay. Let's see, McEwen, what is a to the first squared? Right, because there's a 1 there. A to the second, good. Because 1 times 2 is 2. All right? All right. Jordan, I have b to the -2 to the second. What is that exponent going to be? Very good. Okay. All right. Then, because these two parentheses are right next to each other, this is essentially this. 2a squared b to the 4th. Okay? Okay. How can I do this? What's happening here? I'm multiplying these things, right? So what can I multiply? What am I multiplying? It's the first thing you would multiply. 81 times 2. What's 81 times 2? 162. Okay? What do I multiply next? Both a's. What's a squared times a squared? A squared times a squared is b to the 4th. Listen to what you said. A squared times a squared is b to the 4th. A to the 4th. Okay. How did you get 4? Curious. You added them. Good. And I get 2 times 2, it'd still be 4, but I want to hear that you know that you're adding these exponents and not multiplying them because we're not taking an exponent to an exponent. Okay? And let's see, Fraser. B to the -4th, b to the 4th, what am I getting? Right, so I don't even need it. So this is my answer. Was that? Okay, is there another one in here you want to do? We got about 5 minutes. G. I heard G. Okay, shipping container is in the shape of a cube. Okay. Okay, looks something like that. Does that work? Okay. With sides, okay, so a cube. What do I know about the sides of a cube? They're all sides. And so if one side is 3x, then all sides are 3x. And if we want to know the volume of a cube, does anybody know how to find the volume of a cube? Okay, so what's the length here? No, you guys are missing it. 3x, 3x, and 3x. All right? Abby, what's 3 times 3 times 3? You don't all have to turn. That's the most intimidating thing in the world is somebody calls on you and then everybody in the room turns to look at you. 3 times 3 times 3? What's 3 times 3? Okay? All right, so just the 3's. All right, I've got 9 and then 9 times 3 again. So what's 9 times 3? 27. All right, what's x times x times x? What to the third? X to the third. Okay, so I get 27x cubed. And this is cubic inches. I suggest a picture. Okay. F? Okay. F. I think I've got 3 minutes. I'll try. F. I feel like I just did F. Oh, well, I did D? Oh, your D and my D are not the same. I'm going to have to see somebody else. Well, tell me what your F says. Is it? Okay, so parentheses, negative X. I don't even have this question. Over 7y to the fifth squared. Okay. Let's see. So, this is negative x to the first over 7y to the fifth squared. So, nothing really all that much different happens here. This is still negative x, except 1 times 2 is 2. What's 7 squared? 49. What do you think happens to the 5? It's 5 to the second, so it's, okay, I should get negative x squared over 49y to the 10th. I don't have a negative exponent. That's only exponents. Okay? All right, we'll see you guys.